So in our next section, we're going to begin our discussion of what are actually the changes between the version 4 and the version 5 blueprint, and then also talk about the changes that have been introduced into the actual hardware. So like I mentioned, we're going to talk about what are the topics that have been added to the new exam, which of them have been removed, and then which of them have moved from the lab exam to the written. We'll see that some of these topics that you used to have to configure, for example, performance routing and OER, have moved from the lab to the written. So in this case, you just need to know from a theoretical point of view, what is it and how does it work? Then we'll spend really most of the time in this section is probably going to be about the new hardware specification, because so many people have questions about how do you actually build this if you wanted to use it at home, and specifically how are we going to be offering it for our rack rentals and so on. Like I mentioned, then that's going to be the second portion. So what are the hardware specs, what are the software specs, and then what platforms can you use actually to complete the exam. So first let's talk about the written exam. There's a number of different things that have been added to this versus the lab, probably more so in the written than the lab, but we'll see a lot of these are very general, like what's the difference between iOS and iOS XE, how does Ceph work from a high-level overview. This is probably a lot of the stuff that you already know just from dealing with the generals of the technologies to begin with. Like iOS, for example, is a single hardware image where everything is compiled into one, where iOS XE is more of a modular format, where iOS runs as a process inside of XE. So that means that if the exec process crashes, you can switch over to another one, because it's basically like running a virtual machine inside of a hypervisor. So this type of stuff we're not really going to get into today. The very high-level overview stuff, Ceph, iOS XE, iOS, there's a lot of other documents that I'll show later as to where you can go for this type of information. Explain general network challenges. Again, this is very generic, so we're not going to be going into it today. Same as like basic IP, TCP, UDP operations. Ideally, you should already know this. If you haven't already read books like TCP IP Illustrated or Routing TCP IP, then I would definitely recommend to look into those for just the generics about how IP works from a layer 3 and then upper layer point of view. Describe chassis virtualization and aggregation technologies. We'll talk about this in the new ATC as it relates to the LAN switching section. Specifically, this talks about things like stack-wise for the access level switches like the 3750s and 3850s. In upper level platforms in Catalyst, this would be talking about the virtual switching system, VSS, or in the case of Nexus, this is what they call virtual port channel, or VPC. Basically, what this allows you to do is to do a port channel or an ether channel that terminates on multiple upstream switches. So let's say, for example, you have your in server and the server has two NIC cards, one going to one switch, one going to another one. Well, traditionally, you could not channel those together because you couldn't channel to two different switches. Okay, virtual chassis aggregation, that's essentially what it allows you to do. So from the end host point of view, they think that the upstream two switches are actually one logical box. So then you can configure the end link as a port channel, and then you could do load balancing essentially between both chassis at the same time. So like I mentioned, we will get into that in more detail in the LAN switching section, but it shouldn't be tons of details that you need to know specifically about it. Then we have explained PIM snooping, which is kind of surprising. I'm not really sure why they decided to add this to the written exam, because it should have already been there before. PIM snooping, of course, we'll talk about in the multicast section in the new advanced technologies class when we get to multicast. But basically what this means is that it allows the switch, the layer 2 switch, to figure out what is the router's port that is attached to the multicast domain. So that's where the switch is going to be listening to things like the IGMP queries that are supposed to come inbound, because that's going to be the router that's forwarding on the port. But in reality, when you're studying multicast to begin with, you should already be knowing what this particular feature means. Then we get to some of the more in-depth ones. So describe WAN rate-based Ethernet circuits. This would be like Metro Ethernet or maybe Q&Q tunneling. This also could be if you're buying MPLS service that goes over Ethernet, like an MPLS point-to-point EVC in each Ethernet virtual circuit, or point-to-multipoint if you're doing virtual private LAN services over MPLS. Basically means it's just an Ethernet port handoff to the customer. Now they're talking about rate-based here. Normally what this means, like you buy a gig circuit, but you don't actually have that bandwidth dedicated to you. So your port on the switch or your port on your router might be a gig port, but they say you're only allowed to send 100 meg or 200 meg. So that means that the provider is going to be policing their traffic inbound, and on the customer side you would want to be doing shaping in order to match their rate outbound. So there's really nothing special about this other than normal Ethernet QoS that we're going to cover anyways in the QoS section. So it's really not that big of a deal. It's just that most people are using Ethernet as their last mile access now, as opposed to legacy serial technologies like ATM or like frame relay DS3, for example. Describe BGP fast convergence features. This would be like BGP prefix independent convergence, BGP PIC, or possibly BGP next hop tracking, BGP NHT. For these type of features, I'm going to be putting together a big list of recommended readings that you should go through. Most of them are going to be links onto Cisco's website that are going to be either design documents or just configuration documents. So for example here, with this one that is describe BGP fast convergence, if you were to search for BGP PIC, which is PIC Edge and PIC Core. And you'll also see that we have some write-ups on this on our blog because it's a feature that's been around for a while. Basically what this does is, let's see if they just show a basic diagram of it. That on your edge routers, okay, so they're saying the edge routers here are router 3 and router 4. They're saying I have multiple paths in order to get to this customer. But one of them normally is going to be primary, and one of them is going to be backup. So one of the issues with BGP is that if you go through the normal convergence type design, if you want to change from one path to the other, you first need to tell all the routers, okay, the old path is gone, and I do that with a BGP withdraw message, and then advertise the new path with a BGP update. So normally that takes quite a bit of time. You know, it could be 5 seconds, 10 seconds or more, depending on exactly what the network is designed for. So BGP prefix independent convergence, you can think of this as kind of like how EdgeRP has your active and standby path. So it has the successor and the feasible successor. It basically allows BGP to learn about the backup route and then install it in the fib, which is essentially the Ceph table, as a backup path when the primary link goes down. So the idea here is that router 3 says I'm going to route directly to the customer, but I also have a backup route through some other router that is also connected to them. So if my directly connected link goes down, I don't have to reconverge BGP. The only thing I need to do is flush the old entry out of the forwarding table and then install the new entry in there. So it gives you much faster convergence when you're dealing with these type of designs, and that's going to be one of the things that they're talking about here, that you would want to make sure that you're not using the normal BGP update and withdraw process in order to do convergence. And like I said, I'll put together a number of recommended reading links for documents that talk about this specifically. Next one is kind of interesting. They added ISIS back to RNS again. So originally it was off, then it was on, then it was off, now it's back on. So this is not going to be from a configuration point of view though. So you just need to know from a general technology point of view, what is IS to IS, what are the features that it supports. Realistically though, if you understand how OSPF works, then you already understand how ISIS works. It uses the same logic of building the topology in two-level hierarchy, where OSPF uses the backbone area and non-backbone area. ISIS uses level 2 and level 1, same exact type of logic. Uses the same SPF algorithm, the Dijkstra shortest path first, or SPF, excuse me. So you'll see that the protocols are very similar. There's some things that ISIS can do that OSPF cannot do, and vice versa. So from a design point of view, there are cases where you would choose one over another, and that's probably what they're going to be getting at here in the written exam. So why would you want to use ISIS to begin with, and what would be the use case where it's more appropriate to choose it over OSPF or choose it over another type of routing protocol? The next two describe basic layer 2 VPN wireline and LAN services. These ones we are going to talk about today in more details. So this is what is sometimes referred to as an Ethernet virtual circuit, an EVC, or sometimes it's called a point-to-point pseudo-wire, or sometimes called any transport over MPLS. There's a lot of different terms for what this is, but basically it means it's a point-to-point Ethernet link that uses MPLS in the middle. So this could be like a Metro E type of situation, or it could be in the second case where it says LAN services. That's where basically you plug your routers on the customer side into the service provider network, and then the end result is that all the customer sites look like they're on a big LAN segment. So specifically today we'll talk about that when we look at different VPNs. Why might you choose point-to-point Ethernet service or point-to-multipoint Ethernet service versus something like just running DMVPN over the internet, or buying L3 VPN service and then running Get VPN on top of it. So it's more of a design issue when you would want to use one versus another, but really you need to understand what does it do to begin with before you can say, yes, this might be appropriate for my solution, or no, this is not going to work in this particular design. Then describe group encrypted transport, or Get VPN. Get VPN we'll see is an IPSec-based VPN that is used to encrypt the payload of traffic, not put traffic into a tunnel. So there's very limited application of Get VPN. Normally this is going to only be used when you already have your own private layer 2 transport, like an MPLS layer 3 VPN or an MPLS layer 2 VPN. But we'll see specifically why you might want to use this versus the other technologies. It's basically a scalability technique for IPSec, where it cuts down on the amount of encryption and decryption keys that you need to maintain, and it makes the rekeying or the renegotiation of IPSec tunnels more efficient than the normal default design. So this one we will talk about in more detail today. Describe IPv6 network address translation. Pretty straightforward. It's just like IPv4 NAT pretty much. Use iOS troubleshooting tools, which we will go over in detail today, which are going to be interpreting packet captures and applying troubleshooting methodologies. So applying troubleshooting methodologies, that's pretty vague. And when we're studying for the lab exam and using show commands, using debug commands, using the embedded packet capture, we are already applying troubleshooting methodology, so that's kind of implicit. But the interpreting packet capture, we will specifically look at that today, exactly how do we do that. Implement and troubleshoot bidirectional forwarding detection, which is actually very, very simple. It's actually only just 1 or 2 commands to turn BFD on. The real thing is, why would you want to use BFD to begin with? So there's certain cases where it will help you. There's certain cases where it's not going to help you. So we'll talk about that in more detail when we get to next class, which is going to be on the optimizations and new features in routing protocols. Then implement EIGRP in a multi-address mode or a named mode. As I mentioned, this is a new enhancement to EIGRP that unifies the syntax between IP version 4 and IPv6. And it also allows you to do some other additional features like IPv6 VRF Lite for EIGRP. EIGRP metric scaling, which is going to be needed when you have very high-speed links like 10 gig, 40 gig, 100 gig Ethernet. If you run regular, normal, classic EIGRP over those, you lose visibility as to the differences in the speeds and delays of the links. So we'll talk about that from a theory point of view in next class, and then also from an implementation point of view. Implement, troubleshoot, and optimize EIGRP convergence and scalability. Like I said, we'll talk about new things like OSPF loop-free alternative, EIGRP fast reroute, and why specifically you might want to use that in your particular design. Implement and troubleshoot DMVPN. That's what we're going to be talking about today, is probably the biggest topic that we're going to be looking at. And you can almost think of this as pretty close to a one-to-one replacement of frame relay. So we'll see that when we configure the IGP routing protocols over DMVPN, since DMVPN is a hub and spoke based IPsec tunnel network, the end result is that it behaves just like frame relay hub and spoke or ATM hub and spoke or any other legacy WAN type hub and spoke design. There are, of course, things that are specific to DMVPN that are different than those other topologies, but from a very high level overview, it behaves very much the same as those legacy hub and spoke type networks. So this one is not only on the written exam, but it's also on the lab. Then implement IPSec with pre-shared keys. We'll see that this is pretty straightforward as long as you understand the basic steps of IPSec and the basic logic. The biggest thing with this is that it's easy to make a mistake, and if you don't know where to start your troubleshooting, it's very easy to get lost. I would say probably crypto configs are one of the top 3 things that are most difficult to troubleshoot in a network design, because there's so many different individual pieces that can go wrong in the crypto config. Then lastly, implement and troubleshoot IPv6 next first hop security. We'll look at that in next class, which is, like I mentioned, it's very similar to things like DHCP snooping, IP source guard, and IP version 4, but now we're running it in IP version 6 as well. Okay, so next, what has been added to the lab exam? So similar to the written exam, some of these overlap, which is going to be the troubleshooting tools and then interpreting packet capture. So like I mentioned, that's going to be the first thing that we're going to look at configuration-wise today, which is how do we use the EPC, the embedded packet capture feature, how do we export the packet captures to a machine running Wireshark, and then how do we actually look through the packet captures to see what's going on. Implement BFD, implement EIGRP and multi-AF mode. We'll look at those 2 in next class when we're talking about routing protocol enhancements. Implement OSPF and EIGRP scalability and convergence enhancements. We'll be covering that in next class. DMVPN we're going to do today. IPSec we're going to do today. And IPv6 first hop security we're going to do in next class. So today is mainly going to be focused on these changes, things about the topology that's changing, and then IPSec and DMVPN, because both of those are pretty involved on their own. Now, there are also some topics that they left in the scope, but they took them off the lab. So, for example, you're not expected to be configuring IP version 6 multicast anymore, but you need to know what it is. Same thing with RIP-NG, or RIP for IPv6, and also IPv6 tunneling techniques. So I would assume this means that they're not going to test on things like automatic 6-to-4 tunneling or isotap tunneling, but still within the scope is going to be maybe IPv6 over GRE. Maybe it's going to be IPv6 over DMVPN. So technically that's a tunneling technique. You could run IPv6 in IPv6, or you could run IPv6 in IPv4. So to tell you the truth, I'm not 100% sure exactly what they mean that's been moved here, because if you want to run IPv6 over DMVPN, that's a tunneling technique. It may not be an IPv6 specific technique, but it is still a tunnel. Also then, describe device security with iOS AAA with TACX and Radius. I'm assuming what this means here is they're not going to test on things like per command authorization anymore, or doing user exec authorization and privilege commands and things like role-based access control, because realistically that should be more reserved for the security exam. So you do of course need to know what is AAA, what are the applications of it, why would you use TACX versus Radius, but we don't really need to get into the details of how do you do all the authentication, authorization, and accounting configs. Same goes with 802.1x. More so than ever, the scope of 802.1x is huge in a real implementation. So probably a third of the security exam is just related to .1x now. Things like .1x with network admission control, with the identity services engine. So it's simply too large of a scope to leave it in the RNS exam. So you need to know what is .1x, but not all the implementation, because turning it on the switch doesn't really do you anything unless you have the actual supplicants and the servers to do the actual .1x implementation. So that's more kind of outside of our scope now. Then layer 2 QoS, since we're not doing hardware-based testing anymore, then the platform-specific stuff is gone, which I definitely agree with here, because if you look at this from an implementation point of view, when you go to apply QoS on different platforms, most of the time you're not going to memorize how does this line card on 6500 do it differently than this other line card on 4500. Normally what you would do is reference the QoS SRND, and it shows you if you want to accomplish this on 3750X with this particular version, here's the syntax. If you want to accomplish it on 6509 with this particular MSFC and this line card, this is the syntax. Because there's differences between the hardware implementations, so it really doesn't make sense for them to test on how it's implemented on one platform versus another. So we do, of course, need to know how does layer 2 QoS differ from layer 3 QoS? What can you do? What can you not do? But we're not going to be doing the actual configuration on the switches anymore. And then last but not least, what a lot of people are happy about is that performance routing, and some people, Brian Dennis is not happy about that is going away, is performance routing or optimized edge routing. This is, I would say, probably a good idea because there's so many different variations between the code trains on how PFR works, and ultimately this is going to be what's rolled into the SDN applications like 1PK and stuff like that. So it's good to know what is PFR and what could you theoretically do with it, which is like automated scripting of the routers to do changes of the routing table, but it's no longer in the lab exam. It's now specifically just in the written exam. Okay, then last but not least, what is completely gone? We have in layer 2 LAN switching, flex links, ISL, and layer 2 protocol tunneling. ISL definitely makes sense because most platforms don't even support it anymore. There's no advantage of running a proprietary trunking encapsulation versus running .1Q. So really no feature differences. Layer 2 protocol tunneling and flex links, they probably took these out because I'm assuming IOL, the actual layer 2 virtualization they're using, probably doesn't support these features. But in reality, they're very simple configs to do. So it's a good idea to know what is flex links, what is L2TP, but we're not going to be looking at the actual implementation. The biggest change, of course, is that frame relay is gone. So frame relay, all of the other nuances with it, like multicast over frame relay or IGPs over frame relay traffic shaping, all of that stuff goes out the window. Now we will see today, though, when we're talking about DMVPN, from a layer 3 routing point of view, there are a lot of similarities between the two topologies. So if you do understand how legacy frame relay hub and spoke works or legacy ATM hub and spoke works from a routing point of view, then you already have a pretty big head start on how it works over DMVPN. Then we have the Web Cache Communication Protocol, WCCP, which makes sense because this should now be more geared towards security when we're trying to do packet intercept and then redirection for things like the Ironport Web Security Appliance, or if you're doing it for WAN acceleration, the WAS appliance. Basically, you're just capturing the packet and then redirecting it to some sort of collection station. But probably this is not supported in their software virtualizations as well. iOS firewall and IPS, which makes sense because that, of course, is more geared towards security, especially now with the zone-based policy firewall. It's not a simple config. There's a lot of detail that is involved with the iOS firewall feature set now, so that's better left towards the security track as a whole. Also, the iOS IPS is kind of a legacy feature. Nobody really uses it, honestly. IPS is more going to be in the ASA-CX or in the dedicated intrusion prevention system platform, like the IPS 4200. Then we have router IP traffic export write, which we'll see is kind of a legacy feature now. There's not as much application for it anymore now that we have embedded packet capture. So write was when you basically took IP packets in and then you redirected them out another interface. You could think of it like a SPAN, a switch port analyzer, but on the router. Then we have Armon remote monitoring, which there's not a ton that you really would do with Armon anymore. Most anything that you can do with Armon, you probably would do it with SNMP instead nowadays, realistically. Then the router group management protocol. This is kind of a legacy multicast protocol. To tell you the truth, I don't think anybody even knew it was in the scope to begin with. But from multicast, RGMP is gone. And then lastly, RSvP QoS and weighted round robin and shape round robin. So these, again, are layer 2 QoS features. RSvP QoS is legacy, honestly. The only thing that this would relate to would be MPLS traffic engineering, which is outside our scope anyways. That would be for something in the service provider exam. Okay, so there's a couple questions on here. Isn't PFR 2.0 something Cisco could spring on us in the lab? I'm going to say probably not, only because they specifically said that it's moved from the title of that slide is wrong, is what someone mentioned. That should say move from the lab to the written. So this was stuff that was in the lab, now it's in the written exam. So personally, I don't think that they're going to test on PFR 2.0, since they specifically went out of the way to say that it's going to be on the written, but it's not going to be on the lab exam. There's another question. Do we apply the principles of point-to-multipoint broadcast, non-broadcast, and loopback and OSPF over frame relay in DMVPN as well? Very good question. We're going to spend a lot of time talking about that today. Yes, you do apply those same type of logic onto it. So when we're running OSPF over DMVPN, when we're running EIGRP over DMVPN, when we're running multicast over DMVPN, it's going to have a lot of the same behaviors as we were running it over frame relay. So even though frame relay is now gone, in spirit from a design point of view, it's still here because DMVPN is a hub and spoke topology like frame relay typically was. Okay, so let's talk about the other big change, which is going to be what changed in the topology in terms of the hardware and the software. Now, there's a couple of relevant documents that you would want to see from Cisco's website. The first one is going to be this transition document, where I don't know exactly offhand where the link is on Cisco's website, but it's the routing and switching lab and written content updates. And basically, this is the high-level diff between the V4 and the V5 exam. So it shows, what are those topics that were added, which ones were removed, and then it also talks about the particular topology. So specifically what this document says is that the configuration portion is now delivered using virtual devices, just like the troubleshooting portion of the exam. Virtual routers and switches will be used throughout the exam, supporting more realistic and bigger network topologies that improve the reliability of the test while focusing on conceptual technologies rather than testing specific hardware platform peculiarities. Ugh. So basically what this means is that the topology size is now arbitrary. You could get a configuration lab that has 6 routers, you get a lab that has 60 routers if they wanted to. But from a fundamental theory point of view, it shouldn't really matter, because the behavior of the technology on 6 routers is the same as it is on 20 routers. But really what they're trying to do here is to get away from the hardware-specific stuff. So like I mentioned, Layer 2 QoS, there's tons of differences and tons of caveats between the platforms, so that's not something that's really applicable to test on, because you need to read the hardware release notes in order to figure out the actual implementation. So they're trying to get away from hardware-specific stuff and look at just more software features in general. That document also talks about what is their hardware specification. It says that if you wanted to prepare for the exam and you wanted to do it on hardware, you could do it on 2900s running 15.3T and a 3560X running 15.0 SE. So this is just one example they're giving of a potential platform that you could use. It doesn't mean that you necessarily have to use this exactly. And we're going to talk about here next specifically what can you use, what do you gain, what do you lose between the different platforms. It says also any other hardware platform could be used as long as you're running version 15. And also you could use older platforms still. The vast majority of features will be there, and then you can use the feature navigator in order to compare the different images. So I'll actually go through this today. How do you use the feature navigator and how do you look at one platform over the other? And that can give you some ideas if you're thinking about buying something like a 2900 versus a 2800. It can show you specifically what are going to be the software differences between those two particular images. Now for our previous topology, we were using 6 routers with 12.4T and 4 switches with 12.2 SE, 3 backbone routers, and a frame relay switch. So from a visual point of view, there was a lot of serial connectivity in this previous topology, both to the frame relay switch and to the routers as back-to-back links. The new topology that we're going to be using is 20 virtual routers and 4 physical switches. Now, if you want to build this topology, it's really up to you whether you use virtualization or not. And I'm going to get into the specifics of how could you build it virtual, how could you build it in hardware, and why might you want to do one versus another. Now, from a physical topology diagram point of view, this is now how our network topology is going to look, where all of the routers logically are connected to the same virtual switch inside the hypervisor, and then there's a physical link that goes out to the physical switches. So you'll see that in the Advanced Technologies Labs for version 5, 99% of the topics you don't need the switches for. You can do them just on the virtualization in here. Anything that is specific to LAN switching, of course, is going to be done on the switches. But overall, this is probably, I don't know, 10, 15% of the exam, maybe. And I think they specifically say that in this document. What is the what's the distribution of topics? So they're saying for the lab 20%, give or take. But layer 2 technologies, this doesn't necessarily mean just LAN switching. Okay, so this is essentially what the physical diagram is now going to look like that we are using. When you go to build a logical diagram off of this, you'll see that the routers are simply going to use subinterfaces and .1q trunking, .1q VLANs in order to actually build the logical network. So at the end of the day, it makes the topology very flexible, and it makes the topology very simple to build if you wanted to do it on your own. So here we see an example of the physical topology. If we were to look at an example of the logical topology of this, let me find my logical diagram here real quick. Logical diagram would look like this. So this is the logical diagram that's going to be used for the vast majority of sections of the Advanced Technologies Labs. And basically, instead of having the mix of routers, switches, and a backbone routers, we're essentially doing it all with just the virtual router instances. So it makes it more flexible in terms of, let's say you wanted to add a new link in the topology, and you wanted to add a new link between, let's say, router 4 and router 2. The only thing that you need to do is just to create a new subinterface and just put IPv4 or IPv6 addressing on there. Because from a virtual switching point of view, the vSwitch that is connecting the routers is going to trunk whatever VLANs that you want across it. Now, if you want this to interact with the physical world, essentially what you would then do would just be to take your physical boxes, like the switches, and then this is just going to be a .1q trunk. .1q trunk. So this would just trunk all VLANs that you're using on the routers, and you could logically build the topology like this, where you could have router 1 connected to switch 1, switch 1 connected to switch 2, switch 2 connected to router 2. So even though it doesn't look like this physically, you still could build it this way from a logical point of view, because the only thing you need to do is just change the VLAN assignments. Now, in most of the material, we're not really going to be using the switches, though, because any routing technique you can do on the switches, just do it on the routers instead. The switches are mainly going to be just for the core layer 2 LAN switching topics. So things like VLANs, VTP, trunking, Ether channel, spanning tree, both in legacy and rapid format, and then some minor things with layer 2 security, like DHCP snooping, IP source guard, private VLANs, port security, those type of things you would also need to know from a layer 2 perspective. But outside of that, the rest of the scope can be done exclusively on the routers. You'll see there's not a ton that you need to know exactly with, or that you will need to do with the physical switches. But this is basically what it looks like from a physical point of view. So it basically, like I said, it makes the network a lot more flexible. It also means that when you're doing things like changing between initial configs, then it makes it a lot faster in order to actually do these changes. And I'll show you guys today, I'm going to go through a basic demo of like how you would rent a rack, and then how do you get under the CSRs, how do you do a basic initial config and then switch between them. And one of the main advantages of this is that the platforms run much, much faster than they did before, in terms of from when you go to initialize them until when they're actually ready to take the configurations. So in our previous system, something that might have taken 15 or 20 minutes to load initial configs takes literally 5 to 10 seconds in the new format. So you'll see this will be one of the advantages of, if you want to use our rack rental system, you'll save a lot of time versus switching between physical devices and switching between configs. Now, if you were to build this topology physical, this would be an example of what it might look like. So you have whatever number of routers. You could have 20 routers, you could have 10 routers. It's really up to you how many that you want. If you wanted to make this on basically a one-to-one basis with how our topology is going to work, then you would need a fifth switch in order to basically aggregate everything into one single link. So you technically could connect these routers directly in here, but the difference is that you would be doing other switching config on this box that's not part of our initial configs. So if you just copy and paste solutions or copy and paste initial configs, it's not going to 100% match up if your network looks like this one here. So you could do it without the breakout switch, but the breakout switch could be anything. It could be like 2950 or it could be like 3550. And if you're already investing in equipment, I mean, this switch could be like $50. It could be like $20 literally. Okay, so let's talk about options for actually building the topology if you were to do it virtual. If you're going to do it virtual, the ideal platform is going to be CSR 1000V. Now, if you haven't heard of this before, basically what CSR 1KV is the ASR 1000, which is the replacement for the 7200. So it's Cisco's main edge router with the code compiled for virtualization as opposed to be compiled for hardware. Now, this is different than something like IOU or GNS3 though. CSR 1000V is a production router. So it means that it has actual TAC support for the code base and the features actually work. So you can use this as your router. Packets come in one virtual interface, they go out another one. This is why it should be the preferred method of testing these protocols if you're to do it in virtualization. Because if you look at something like GNS3 or IOU or IOL, they are essentially simulating the network. It's not a real actual implementation. So you'll see that there's certain things that you might be able to put the configuration in GNS3, but it won't actually work. And especially when you get to your later stages of preparation, it gets really, really frustrating, wasting time troubleshooting something that ends up to be a simulator problem or an emulator problem and not an actual configuration problem. So as far as I have seen so far, every single thing that I have tested on CSR 1000V works because it's an actual implementation of the code. The only difference is that you don't have physical interfaces, you have virtual NICs, and you're routing the packets between the VNICs. Now, the only other thing that it doesn't support, though, is serial links, which we don't really care about because even though PPP and HDLC is within the scope of the exam, it's going to be 1% of the scope. So you could do those topics in GNS3 in 5 minutes, or you could do them in regular hardware routers in 5 minutes. You go to the serial link, say clock rate, whatever the number is, encapsulation PPP, congratulations, you got a PPP link. So it's nothing that's really that big of a deal that would warrant continuing to keep it in the topology. Now, I would assume that when you get to the actual lab exam, there will be serial links in there that you deal with, but they're really no different from a behavioral point of view versus a point-to-point Ethernet link. So from routing, you may see some differences like OSPF defaults to point-to-point network type versus an Ethernet interface where it defaults to network type broadcast. But from an upper layer functionality point of view, it's really going to be identical regardless of what the underlying transport that you are going over. Now specifically, the CSR 1000V, since it is a compile of the ASR code, it runs a version of the S train, which is the service provider train. So in the case of the 7200s, where this originally came from, was 12.0S and 12.2S. Now the service provider trains in general are higher trains than the equivalent enterprise ones. So if you were to compare 15.4S to 15.3T, the S train will have more features in general, not all the time, but most of the time. So you can't really compare them on a one-to-one basis. And if you do compare them in the feature navigator, it's probably not going to give you the right output as to what is supported and what is not supported. But like I mentioned, essentially 99% of what we need to do is going to be in the CSR 1000V. Now, if you are running it, yourself. So if you want to build your own lab and use CSR, I would highly recommend to run it on a bare metal hypervisor. So do a bare install of VMware ESX, do a bare install of Linux KVM, do a bare install of Zen Server, and then install CSR on top of that. I would not recommend to run virtualization inside virtualization because you end up in some weird end results. So if you have Windows on your laptop, don't run VirtualBox and then put CSR inside of it. It's not going to perform the way it's supposed to. I have a pretty powerful desktop, the machine that I'm using right now. I tried it out the other day inside a VMware workstation. It's really not going to be worth your effort if you want to do it this way. So figure if you want to build the topology, use a dedicated box to do it. Don't try to run it on top of your laptop. Now GNS3 is a different story though. You could run these versions like 7200s with the 15.2S train, or you could technically run the IOU or IOL code inside of GNS3. But again, the main difference is that not all features are going to be stable and not all features are going to be supported. So you also can technically run the CSR inside of GNS3, but again, you probably don't want to do that because it's too many layers of virtualization. It overcomplicates the overall design. So you may consider doing a mix of this as well, like, I want to test out basic DMVPN, spin up 3 routers in GNS3 and do a basic hub and spoke config. So you don't always need a huge topology in order to test these features. It's just you'll see as the content gets more complicated and more evolved, that's where the size of the topology starts to scale. So in the Advanced Technologies Labs, it uses a standard format of 10 routers, but not all of the configs actually use all 10 routers at the same time. So if you had a home lab with smaller routers, you can move that around and just change the questions around in order to match your particular implementation. Now, when we get to things like troubleshooting and configuration, that's when the topology is going to start to scale, that you'll see 20 or more routers in the topology. Now, if you were to do this with physical routers, the ideal platform is going to be ISR G2 or higher. So this could be 1900, 2900, 3900, etc. The disadvantage of doing this is that you need all of the feature sets. So this means from a licensing point of view, you have to buy the maximum license because you need not only the IP base, but you need data for things like enhanced routing, and then you need security for things like DMVPN and IPSec. So if you already have these boxes, that's great. You could run either 15.3T or you could run 15.4T. It's really up to you. But they're saying that their spec is going to be based on features that are in 15.3T. Now, if you have older boxes, there's still a lot that you can still use, though. Probably the 2600s and below are not going to be that great anymore. So you can use them for some stuff, but ideally you would use something ISR G1, like 1800s or 2800s. If you look on the used market, a lot of these are really cheap. You can get 1800s for like $100 or so in the US, but really depending on where you are in things like shipping and customs charges and stuff, it might not really be viable to use physical equipment for this. If you do run the ISR G1s, there is an official release of 15.1T, which is Advanced Enterprise Services. There's also an unofficial release of 15.3, which is some sort of custom compile for the Lisp code. And if you search on our forum, you can find what that particular file name is. I did do a little bit of experimenting with it. There are some features that are in that train versus the other one versus the 15.1T, but the vast majority of stuff is going to be still the same. So you would probably be able to do at least 80%, I would say, if not more, by using ISR G1. So if you have 1841s, if you have 2801s, don't throw them out. You can still use them for a lot of things. You could also combine both the physical and the virtual world together if you wanted to. So where our previous topology for virtualization had this, there's nothing to say that you can't plug your physical routers, router 1, router 2, in here, and then have them interact with the virtual world by going through the hypervisor. So it's really up to you if you were to build this topology, how you want to do it, either all virtual or all physical or a combination of them. There's a lot of factors that are going to be based on it, like how much space do you have, how much do you want to spend, what's power and cooling budget, that type of stuff. Now, from the switching point of view, the switches are a different story. If you want to run the code train that really does every feature that's on the blueprint, then you would need some E or X switch, like Catalyst 3560E, 3560X, 3750E, 3750X. Even though some of the lower platforms can run the 15 train, it doesn't support all the features. So for example, IPv6 first hop security is not supported on a 3560 non-X or non-E, even when it's running the 15.0 code. Now really though, do you care? Probably not, because if you were to build the topology with a non-E or a non-X switch, you can still do 90+% of the switching features. So if you already have these old boxes and they have 32 megabytes of flash or more, they still can run 15.0. Now if you have ones that can only run 12.2 SE, that's probably fine for the vast majority of features. So not everything is going to be 100% there, but it's going to be a pretty good start. The other issue, of course, with the physical boxes, if you use the E's or X's, you need the IP services feature set. So you have to buy the full license. It's not something like the previous iOS versions that just have it in the normal feature set. So these would be running the IP, or not the IP base, they would be running the universal image, and then you need to turn the IP services feature set on. Now let me give you guys some examples of our topology for this. For example, the switches. This box here, let's say show version. This box is a regular 3560. So this is 3560 24TS, which is the regular first generation 3560, but this particular platform has 32 megs of flash, where the PoE versions have 16. So what this means is that if you have a 3560 that is not this exact part number, it's not going to support the code base, which is this one here, the 15.0S. So you'll see these on, and let me open up one of the other ones. And let's look at the file size. This is what the issue is. So you can see the two images. This one on this switch 1, this is the 15.0 SE, and it's about 17 meg. But this box has 32 meg of flash. The other image, which is the normal 12.2 S release, is 12 meg. So you can run this on any of the boxes. But if your box doesn't have 32 megs, then you cannot run the 15 release. Now the boxes that run the full-blown versions, these are the ones that we already have in our security topology for security version 4. So this one, if we look at the show version, this guy is 3750E and running 3750E universal 15.02 SE. And I believe it should have, if we show license, this has IP services permanent. So if you look at these two, so forget the old one that's running the 12.2 for now. If we look at the show version, include iOS on this guy, and compare it to the 3750E, you can see it's a pretty close code train. The regular 3560 is running 15.02 SE. The other one is running 15.02 SE2, so it's only one maintenance release off. But the difference is, if we say IPv6, like IPv6 source guard or source guard globally, IPv6, that one's not supported in the regular 3560. So really this is only pretty much the main feature that is not supported in the lower level switches that are still running the 15.0 code. But what I would recommend to do is just rent some rack time from us to do the IPv6 first hop security, because really in the scheme of things it's a very minor feature. Otherwise, most of the switches that we're going to be using are going to be either the 12.2 release, the 12.2 SE, or the 15.0 release, because from a LAN switching point of view, like spanning tree and Ether channel, there's really no changes in the differences between the 12 and the 15. Now for the CSRs, like I mentioned, the CSRs run no, that's the wrong box. The CSR version, they call it 3.11s. This is the iOS XE naming convention, but it relates to what they call the iOS-D, the iOS daemon, which is 15.4s. So essentially anything that is in the physical boxes in 15.3t will already be in the CSR 1000V. Really the only other difference besides this in the serial links is that when you look at the let's just look at the show run here. Since the interfaces here, like gig 1 versus gig 2, since these are VNICs to begin with, there's no functional difference between using a main interface versus using an interface that has subinterfaces. So for simplicity, you'll see that in our topology, I'm only using one interface, just always gig 1. And then to make the logical separations, it's using the subinterfaces in the diagram. So like if we go back to the topology, this one here, when we're looking at, let's say, gig 1.146, this means that it's going to be VLAN 146. And then from an addressing point of view, you can see over here it says the IPv4 and IPv6 prefix. This will be 155.146.0/24. So same type of logic as before, but now it just runs as a subinterface on CSR. Okay, both for IPv4 and IPv6. Essentially, IPv6 is going to be on everything as well. Okay, there's a couple questions here. Is there a hardware spec available for CSR 1000V machines to create your own INE labs? So do you mean in terms of servers that you could use that would physically support the box? So in general, you need about 2.5 gigs of RAM per instance. So figure if you want to run a full 20 router instance with plus another virtual machine, Windows virtual machine to run Wireshark, you need about 32 gigs of RAM. The CPU is not that big of a deal. You can run the CPU at 100% and it should still be fine for most of the routers. But figure I would say for 20 machines you would need at least 4 to 8 cores total, maybe a little bit less than that. The boxes that we're running them on are much bigger though. So it's kind of hard to tell how this would equate to a smaller server. And let me show you guys real quick what we're using. So here's one of my dev boxes. You can see how many instances it's running. I think it's running like 80 instances plus 4 of the Windows virtual machines. And right now it's using just over 256 gigs and 37 gigahertz total. So let me see if I could do the math here. This is 20, 40, 60. Now it's got 90 instances. But the Windows VMs throw this off because the Windows VMs are kind of greedy with their memory. But assuming that we're running 90 instances, it's just about 2.5 gigs of RAM per instance. And then let's say 28 gigahertz divided by 90, 0.3. So you need about 300 megahertz per instance then, I believe. But these numbers aren't going to be 100% spot on. What I would do is just install it on whatever you have and see how many instances you can boot before it runs out of resources. But the memory is kind of a hard requirement. Technically, you can configure your hypervisor to swap the RAM to disk, but it really doesn't perform that well. So the other question is, I will be putting together a more detailed spec of this, like if you wanted to build it, what specifically could you use? Then if you were to do it physically versus virtually, like what would the cabling be and stuff like that. But the physical topology is very generic now versus how it has been in the past. If you wanted to do this in GNS3, basically the only thing that you would need to do is, and actually let me open up GNS. The only thing you would need to do is just take the routers, and like I said, you probably would want to use the 7200s because they can run the 15.2s code, and then just connect them together with a Ethernet hub. It doesn't even need to be a switch, because basically you just want all of the routers to be on the same segment. So you just take all the links. Well, you need to add the ports on there. But you would essentially just take all the router's links, put them on the same hub, and then just configure the .1q subinterfaces on the routers in order to build the topology. So from a physical point of view, it's very, very simple, much more simple than it's been in the past when we're not talking about getting the physical switches involved. So however you want to build it in order to get the routers to actually be on that segment together, which is again going to look like this, then you could do this however you want. You could build it physical, you could build it virtual in CSR, virtual in GNS3, that's really up to you guys. Now, of course, we are going to be hosting this topology for rack rentals, and is that the last slide I have? Yeah, on switching. The advantage of doing the rack rentals, and let me go through this process real quick for you guys so you can see this. Okay, so once you log into the member site, if you go to rack rentals, just like before in version 4, you'll see that the version 5 scheduler is now available, so click on schedule. Okay, so when you go to the scheduler, let's say like the current slot that's right now. Okay, so it shows you what and you can adjust this if you want, whatever the time is. So right now it's what? It's almost noon my local time. So the previous session started at 11:30. Let's say I want just like 2 hours, 11:30 to 1:30. And then click rent. Yeah, I need to log in. So 11:30 to 1:30. So let's say I want a 2-hour slot. Okay, it says your session is scheduled. If we then go back to, and you'll see the interface for this is going to change over the next couple weeks as more features are added to the control panel. So when you go to it, it may not look exactly like this. But once you rent the session, if you click on the control panel, it'll show you what the specific login info is. And here, like in this case, it says I'm on RSrack3. And then this is my particular password. So if you take whatever your terminal software is, like in this case I use Secure CRT, and you telnet to racks.ind.com RS5 rack 3, then right now we're using a menu. You'll see this will change a little bit later, but it says the 10 routers, and they're already provisioned. So literally between when you rent the rack and the initial configs are loaded and the topology is ready, it's like 15 seconds. And there's also some other tricks that I'm going to show you guys today that if you want to switch between initial configs, there's a really quick way that you can do instead of telling the scripting system, hey, I want to reboot the routers and then load this particular config set. So what you want to try to avoid is doing a reload on these boxes, especially if you have lots of them running at the same time on the same physical host. They start to thrash the disk when they go to read from the NVRAM, and it takes them a little bit longer then to boot up. So you might see some of the routers might take 10 or 20 minutes to actually boot, versus when we switch between initial configs, and I'll show you how to do that with config replace. It takes literally like 5 seconds in order to do it. But these boxes, like I said, if you show version, these are the CSRs, and they're running 15.4s. So our scheduler is available now if you guys want to start booking sessions in order to do these labs that we're going to be going through. There's a question, have I had any time on the XRV? I haven't really. I've seen it boot and just done some very minor basic stuff with it. From what I understand, a lot of the data plane does not work on it, so there's a lot of things that you can't test. What the XRV VM mainly is meant to be used as is a route reflector. So it supports the control plane, but since the vast majority of the XR's forwarding is happening in hardware at the line card, most of the things it doesn't support. Like you can't actually do MPLS layer 2 encapsulation because that's offloaded to the line card. So things like VPLS or Atom that you normally would run on the edge, it's not supported on the XRVM. But just from learning the syntax point of view, yeah, it's great. You can definitely use it to do that. But if you were to, let's say, like you wanted to go through the service provider version 3 labs that we have, you might be, banging your head against the keyboard when you're testing something and it doesn't work. It's probably related to the lack of data plane support on the box. But I think its requirements are much higher in terms of what it needs on the hypervisor host. Could we alter the naming convention in the initial configs to make it easier to upload and extract to devices directly from the zip files? Because they have spaces in them? It should support spaces though. Like when you do TFTP upload and download? Well, actually no, it doesn't. Yes, I'll do that. I'll replace all the spaces with dots. So it makes it easier in one string instead of having white space in the middle for it. But basically what you should be able to do then is just take all those configs and TFTP them to Flash, and then you could do config replace in order to switch back and forth between them if you wanted to do that. But I'll show how to do that in our upcoming sessions when we actually get onto the, and some of the folder names were too long. I'll fix it. Dennis, send me offline what the specific error code that you ran into is, and then I can parse through the configs again and put them in a better format for loading them like that. Okay, so it's getting a little bit close to time for lunch break. So instead of starting the next section now, I'm going to wait until after we take a little bit of a longer break. So if you guys have questions in the meantime, go ahead and feel free to type those in. We'll spend a couple more minutes right now in Q&A. Otherwise, we'll take about a half-an-hour break. And then when we come back, we're going to get into our first technical topic, which is going to be the embedded packet capture, or the EPC feature. About the topology. One of them was on the vSwitch configuration. How specifically do you need to configure the routers to talk to each other? Basically, the only thing that you need to do is just to put them inside the same port group. So for example, here I have a number of different racks that are running on this particular machine. And if we go to the configuration under networking, and of course this is going to be different if you're running it on KVM or you're running it on Zen server. But the only thing you really need to do is just to take all of the routers. For example, there's 20 routers here, and then just put them inside the same port group. The only other setting that you need to put on it is that you set the VLAN to all, which is what VMware calls 4095. Basically, this means is that it sends and receives the VLAN tags with the routers. Additionally, if you go to the properties of the vSwitch, there's another thing that you want to set here is under the, I think here under Edit for the vSwitch, under Security. You want to set promiscuous mode to accept, because what that allows you to do is capture the router's frames, which is basically what we're going to show in this section with embedded packet capture. So otherwise, the vSwitch is treated like a normal switch where it does destination-based forwarding. And if you turn promiscuous mode on, it basically turns it into a virtual hub as opposed to a virtual switch. So if you do want to do packet capture inline, then the easiest way is just to turn the promiscuous mode on for the vSwitch, and then that is going to allow you to do the actual frame captures. There were a couple other questions. What are the licensing requirements for the CSR? There's actually a 60-day demo license built into the VM. So you can, and that's assuming that you turn the license on. One thing that you need to do is when you start the machine, so this one already has it activated, but when you boot the VM up, you need to go to global config and you need to say license boot level premium. This is basically what turns all of the features on, like MPLS and IPSec and so on and so forth. So once you do this, it'll ask you, do I accept the end user license? You say yes, and then you write and reload. Then when you look at the show license, it should say that the eval license is in use, and then it shows you how much time is left. So what's supposed to happen, and I've never actually let it go this far, so I haven't tested it personally myself, but from the documentation, it basically says that once you go beyond this period, it just falls back to the minimum throughput forwarding level, which is like 5 meg or something. But for our case, we don't really care because we're not testing the data plane for most things. We're basically just testing the control plane. So you could just leave the one install on there and let it go past the license period, and it shouldn't really affect anything that we are working on. Worst case scenario, you could just uninstall the VM and reinstall it. You'll see if you go this route, it really is not that difficult in order to do the install and then the reinstall. I'm curious, with the entire exam now being 100% virtual, why would Cisco still require testing at only a few selected locations? Wouldn't it be possible to set up the testing for the lab at the Pearson VUE testing centers? Technically, yeah, they could do it. We'll see what happens once they actually get into the new format and it starts to run for a little while. I wouldn't be surprised if they eventually do that, like they do the CCDE exam, that as long as it's at one of the specific VUE centers that they choose, we'll see they might be able to offer it there as well. Same as kind of like how the mobile lab works for the previous labs up to that point.